Now we're going to talk about what happens as we take limits as x goes to infinity or x goes to negative infinity. So here we're saying if we look at the graph as x goes all the way to the right toward infinity, what happens to the y values? Or similarly, as x goes to the left or to negative infinity. Okay, so to write this out mathematically, we say that the limit of f of x as x goes to infinity equals L if, sorry, let me turn on my pen, if as x moves toward positive infinity, f of x gets arbitrarily close to L. So we're saying as x goes to the right or toward infinity, the y values get closer and closer and closer to L. So they're always, as you go more toward the right, your f of x values are getting even closer to L. Okay, and very similar definition, we say that the limit of f of x as x goes to negative infinity equals L if as x moves toward negative infinity, f of x gets arbitrarily close to L. And we'll talk about this in a minute, but you've probably actually already seen this in previous classes. These are going to be our horizontal asymptotes. Okay, so we're going to use our graphing calculator, and we're going to look at the graph of 1 over x. Okay, so here's our graph of 1 over x. And first it says find the limit as x goes to infinity of 1 over x. So we're saying what happens as we go toward infinity, okay, as our values get bigger and bigger and bigger. And what's happening is this graph is limiting toward the x-axis. So the y value is 0. Now the other way we could see that, if we go to the table, okay, and I'm actually going to set this so I can put in whatever numbers I want. So if I put in something like 10, okay, we get 0.1. Well, what if I put in 100? Then it's 0.01. If I put in 1,000, it's 0.001, right? If I put in bigger and bigger numbers, if I put in 10,000, right? So we're now getting in scientific notation, but it'd be 0.0001. These are all going to be positive values, but they're getting closer and closer to 0. Now if we look at our graph, even though it's coming from the negative direction, as we go toward negative infinity, these values are also going to 0. Okay, so these are some kind of common ones to know, and if you think about this, this should make some sense to you, because we're saying we have a fraction, the numerator is staying at 1. What happens as the denominator gets bigger and bigger and bigger? And so even if you think of small fractions, 1/2, 1/3, 1/4, as the denominator gets bigger, the actual number, that fraction, gets smaller. Now, a theorem is, or how we can expand this, if you have 1 over x to some power and you're taking the limit as x goes to infinity or negative infinity, your denominator there is just it's getting bigger even faster. So these limits are also 0. So these will help us solve some problems later. Now, the graphical meaning, and you've probably seen this in another course, for example, pre-calculus, you hadn't learned limits yet. If your limit as x goes to infinity of f of x equals L, so this is, L here is a finite number. We're not talking about L being infinity or negative infinity. Or your limit as x goes to negative infinity of f of x is equal to L. Then the graph will approach the horizontal line y equals L. Oops. Sorry, I was thinking of our example. So here, when we said the limit was 0, we're saying the graph on either side approaches the line y equals 0. And this line is called a horizontal asymptote. Okay, so we're going to talk more about how to find limits as x goes to infinity or negative infinity, and we'll especially do it with rational functions, but these are the definitions to get you started.